See question number 2. See, in any undirected graph has an even number of vertices of odd degree, right? What is the theorem? An undirected graph has an even number of vertices odd degree. Okay, see. What is this? You know the sum of degree of all vertices is got 2 times number of edges. Okay. If anything, when multiplied by 2 is what? Even? Right? This is even, right? And this is sum of degree. So you will get even what? When? Even plus even is what? Even. And also when odd plus odd, when both are odd, you will also get even. Right? So let's suppose in graph, there are some degree, some vertices are there, which are odd, right? And some have even number of degree. So you know what is this? Either this must be even or this must be odd, right? Yes. So you can say what? The odd number of vertices plus odd number of vertices have what? Even degree. Or even number of vertices, even number of vertices have even degree. So this is the theorem. What? Even number of vertices of odd degree, right? Understood? No, when both are same, then you will get only even. For example, odd plus even. Let's suppose this is odd and this is even. You will get odd. And if no, you break this into two parts, odd or even, right? So this must be what? Even. So this is even only when it is even or it is odd, right? Yes.
जो आपने देखे देखे पहला तो वो है कि हम
Yes. So first PDF had done. Okay. Now already told you what is directed graph, right? Yes. This is simple directed graph. Yes. This is mixed graph. Simple graph, yes. So what is pseudo graph? If multiple graph with self loop. So that's why you can say simple multi graph. Okay. Yes, that's why you name this what? Simple multigraph. Okay. Yes. That's why this is what? Directed multigraph. Understood? This is mixed multigraph. Why mixed? Because some parts are directed and some are undirected. And why this is multigraph? Because parallel edges are there. Yes. Yes. No. You understood? Yes. Already told you in degree, out degree, right? Yes. No. No issue. Yes. Some special type of graph, right? Yes. What is complete graph? This is complete graph represented by Kn. A graph, very important, a graph in which all vertices are connected with each other. Okay. For example, all vertices are connected with each other. This is what? Complete graph with three vertices. Complete graph with four vertices means what? This is connected with all vertices. Okay. This is what K4. K5. There are five vertices. All vertices are connected with each other. So first vertices are connected with each other. Now add second vertices are connected with each other, right? Yes. Now third vertices is connected with each other. And in last, this is what K5. Understood? So number of vertices in Kn is what? N. Number of edges in Kn is what? Understood? And third important point of complete graph is your degree of each vertex. Each n minus 1. You can see if 3 is there, degree of each vertex is 2. Here K4 is there. It means degree of each vertex is 3. This is K5. Degree of each vertex is, you can see, 4. Understood? These three important points are derived from complete graph. Write this. If I ask you how many number of edges in complete graph K5, yes, 10. Right? If you don't use this formula, you can also find the number of edges. How? Degree of each vertex is 4. तो फर्स्ट वर्टेक्स है 4 डिग्री, सेकंड है 4, थर्ड है 4, 4। सो टोटल हाउ मेनी total degree are there? 20. And by hand checking theorem, you know. So number of edges will be 10. Understood? Yes. In any way you can do. If I ask you a complete graph K9, how many number of edges? 36. Very good. And degree of each vertex will be 8, because 9 vertices are there. Yes. So note this. Yeah. Right. This is complete graph K1. Why? Because only one vertex is there. Understood? And number of edges will be 0. Right? Next graph is cycle graph. Cyclic graph. What is cyclic graph? Yes. Cyclic graph is represented by Cn. So cycle always starts with minimum 3 number of vertices. Okay. This is C3. You cannot create C2 cycle. In cycle, the starting and final vertices will be same. This is cyclic graph. This is C5. Right? This is C6. Closed loop with the same initial and final vertex. Okay. Yes. In Cn, degree of each vertices is 2. Okay. Number of vertices is n. Number of edges will be n. Okay. Yes. Hmm. Yes, done. Next is wheel. What is wheel? Wheel is represented by Wn. Okay. An internal vertex is connected with every vertices in a cycle. Okay. Cycle Cn. Let's suppose this is cycle of what? Three vertices. One internal vertex inside the triangle. You can connect all remaining vertex with this one. This becomes what? W3. Understood? Yes. So cycle becomes wheel when an internal vertex is connected. Understood? This is cycle 4, C4. But when an internal vertex is connected with every vertex, it becomes what? Wheel. Yes, W4. This is pentagon. This is what? C5. Let an internal vertex connected with every vertex of C5. Then it become W5. Understood? Yes. So in Wn, number of vertices will be n plus 1. Number of edges will be degree of each vertices. No, no. Degree of each vertices is 3. Not 3. Here 4 and here 3, right? Yes. Degree of vertices is not important. How many numbers of edges? 2 times number of 2n, right? Yes. Okay. One is regular graph. What is regular graph? A graph in which every vertices has same degree. Okay. For example, this is a regular graph. This is R2. Okay. Because each vertex is a degree 2. This is also R2. This is also R2. So number of vertices doesn't matter. each vertex is a degree 2. You can see degree 2, 2, 2, right? Na? Similarly, 2, 2, 2, 2, right? So this is what you can say 2 regular. Sorry, this is 1 regular. Why? Because each vertex is degree 1. 1 regular. This is what? 2 regular, right? This is 3 regular. Because each vertex has degree 3, right? This is 4 regular. Why? Because each vertex has a degree 4. Understood? Yes. Now see bipartite graph. What is bipartite graph? A simple graph is called bipartite if its vertex set we partition into two disjoint set. Okay. A graph is said to be bipartite if G1 intersection G2 is null and G1 union G2 is G. Suppose a graph is divided into two parts. Okay. Such that their intersection is nothing and their union is same thing G. Yes. For example, this is 1, 2, 3, 4, 5. Okay. So this is a graph. In this graph, you can see, suppose this is a graph G. You divide this graph into two parts, G1 and G2. In G1, vertex 1 and 2 are contained, and here 3, 4, 5. So what are common between these two? Nothing. And when you take union, you will get what? Same thing, right? So this is bipartite graph. Understood? Yes, note this. Yes. You divided the original graph into two parts, G1 and G2, such that their intersection is pi and their union is G. Okay. But bipartite is represented by KMN. Okay. So in one set there are m number of vertices, in other set there are n number of vertices. So total number of vertices, very good. A total number of edges, m into n. Okay. For example, how many edges are there? 6. This graph is 2, comma 3. So total vertices is 5, total edges is 6. Understood? Yes. If I ask you draw 3, comma 3, it means what? Every 3 vertices of other part is connected with other 3 vertices. Okay. So how many number of edges? 6. Number of vertices 6, edges 9. Yes. Also draw 2, comma 5. Hmm. Yes. No, you have to find what is G1. 1, let's suppose 2 comma 5, right? How will you decide this is which one is G1 and which one is G2? Draw the graph, right? Okay. So this is G, right? What is G1? No, no, no. G1 contains what? 1 and 2 only. And G2 contains, understood? Such that you can see they have no anything intersection. And when you take union, you will get what? G, right? This is bipartite graph. Now see this. Coloring of graph. Yes. Numbers. For example, this is a graph. You have to color the graph such that no two adjacent have same color. Suppose you color with red, that this you can color with green or blue. Okay. Let's suppose you color with black. Here you can do with white. No, I tell you, don't worry. How many colors you used here? Four colors. Such that no two adjacent have same color, right? This is coloring of graph. But if I ask you, how many minimum colors you can use to color this graph? Suppose you do with red, then this is adjacent and this is adjacent. This cannot be red, right? But this can be red because this is not adjacent to each other. And if you suppose you draw with blue, you also going on. How many minimum colors you used here? So minimum color is what? Chromatic number of graphs. Chromatic number of graph is represented by this. Okay. So what is chromatic number of graph? Minimum number of colors used to color the graph. Okay. But if you are asked to find the coloring of graph, that is not chromatic. If chromatic number is there, then you can say minimum number. Understood? And chromatic number is represented by x of g. Right? What is cycle? Cyclic graph? Okay. So what is the chromatic number of this? Tell me. Tell me. What is chromatic number of this? What is chromatic number of this? 5. How 5? Blue, na? 3 colors you can use. What is the chromatic number of this? Are 2, how? Red. 3 colors. So you can observe one thing, what? Chromatic number for a cyclic graph is 3. Right? If n is odd. Now tell me what is the chromatic number of this? 2. What is chromatic number of this? So chromatic number for a cyclic graph is 2 if n is even. Okay. So always remember chromatic number of a cyclic graph is 3 if what? No, if n is odd and 2 if nice. So this is one of the theorem. This is one theorem. Understood? Yes. Right. For bipartite graph, chromatic number is always 2. Remember this. Okay. This is important point. Any bipartite graph has chromatic number 2. Or you can say if any graph has chromatic number 2, that is bipartite graph. Okay. So what is the chromatic number of this graph? 2. Suppose this is red and this is red. This is green, this is green. Right? A, B, C, D. So you can divide this graph into two parts. A and C taken together and B and D taken together. So taken together with sets which shows same number same colors. So this is what first set of graph. This is second set of graph such that their intersection is pi and their union is G. Now you understood? You can check very easily how a graph is bipartite. Just find the chromatic number of graph. If chromatic number of graph is 2, you can say that is bipartite graph. Understood? Yes. And arrange the same color in one set, which is easily divided into two parts. Right? Yes. Is this a bipartite graph? Let's check. This is A, B, C, D. If it is red, then none of them can be red. This is green. This cannot be green. This can be green. Right? This can be blue. How many colors? So this is not bipartite. Okay? Understood? So you cannot divide into two parts. Okay. Can you tell me what is the chromatic number of wheel? What is chromatic number of wheel? Okay. What is chromatic number of this? This is W3. This is W5. What is chromatic number of this? This is red. So nothing can be red. This is blue. This can be blue, right? They are not directly connected, right? Yellow. This is what? Let's suppose pink. So how many chromatic number are there? Yeah, it can be green. Very good. So how many colors we used here? Four colors. And what is the chromatic number of this? Three colors. So what is chromatic number of this? Yes, very good. The chromatic number of wheel is what? Four. When n is odd. And it is three when n is even. Understood? See, this is even graph. For even it is 3 and for odd it is 4. Understood? No. W4 means what? Cycle becomes wheel when an internal node is added. This is not W4. This is W3. Understood? So you have to remember these points. Yes, yes. It will consider W3, not W4. W4 means what? C4 will be W4 when an internal node is added in C4.